you should understand what purification means. It was taken from the word purify. That is the verb word of purify. Purify simply means you are trying to remove impurities from a substance. You are trying to make it very clean. So when we talk about purification of a chemical substance, it is just a process of removing impurities from a substance in order to obtain it in a pure form. And this is very important in drug design, in laboratory or scientific experiments. We need to ensure that some drugs are pure enough to be consumed. So it ensures that chemicals are safe and effective for use. So that's just the summary of uh, what we are expected to know today. But we have some subtopics. Let me try and type it out. These are the topics that we are going to check together under separation of mixtures and purification of substance. I want you to write down these topics. Sorry. So write down these topics. These are the topics we are going to check for today. We will check pure and impure substances. We will check boiling and melting point of substances. We will check elements, compounds, and mixtures. We will check chemical and physical changes. We will check separation processes. These are the examples of the separation processes that we will check. We will take it from the simplest one to the complex one. So that is what we are going to check today. And if time permits, we will go into the second topic, the second topic that you're expected to know in your JAM chemistry syllabus. So by the end of today's topic, looking at this topic, you must be able to distinguish between pure and impure substances, because they will test your knowledge. Can you distinguish between pure and impure substances? So by the end of this topic, you should be able to distinguish the difference between pure and impure substances and examples of pure and impure substances. And also, you must be able to use boiling points and melting points as a criteria for purities of chemical substances. You must be able to use the boiling point and the melting point of different substances as a criteria to understand the level of their purity. And you must be able to distinguish between elements, compound, and mixtures. The C aspect, many times you don't ask questions on this because it is too simple, but you can be lucky. They can give you a compound and ask you, is it an element, a compound, or a mixture? Things like that. And at the end of this topic also, you must be able to differentiate between chemical and physical change. What are chemical changes? What are physical changes? These are the things you're expected to know in this class. Another thing you're expected to know after this class is to identify the properties of the components of a mixture. What are the properties of a component of a mixture? All these things will be explained. I don't want you to fidget at all. You will understand it. And we are going to consider some past questions in JAM, chemistry JAM, so that we can test our knowledge. And the last two things you need to know at the end of this class is to specify the principle that are involved in each separation method. They ask for principle. What are the principles that are involved in evaporation? What is the principle that is involved in simple distillation or fractional distillation? And they can also ask about the application of basic principle to the separation processes in everyday life. They can ask for the application. So I don't want you to scare at all, to get scared at all. Everything will be fine. Don't worry. So let us take it one after the other. Let's start from this first one, pure and impure substances. Pure and impure substances. So I want you to jot down everything I'm explaining to you. Pure and impure substances. So if you follow me, I've actually explained what purity means, what pure and impure substances. Pure and impure substances, when we talk about pure substances, it's just a kind of substances that contain only one kind of particles. It does not contain any other thing except one kind of particle. That is what pure substance. Let me just give you the notes. Let me give you the notes. A pure substance contains, I want you to write it down, only one kind of particle. So that is what pure substance is. Any substance that contain only one kind of particle is a pure substances. And another hint that you need to know is that pure substances always have these fixed physical properties. They have these fixed physical properties. So they don't have an anomalous or a variable physical properties. They have a fixed physical properties. For example, we have sodium chloride. Hello, are you still with me? Okay, so for example, we have, let me say, examples of pure substances. Distilled water is there, and any other substances that carry the word pure, like pure potassium chloride, pure sodium chloride, things like that. The examples of pure, let me use sodium chloride, pure sodium chloride. And any other examples of any other substances that carries the word pure. They are examples of pure substances. But that is not our emphasis for today. I want us to move as far as possible in order to finish this first topic. Let's quickly move to impure substances. I believe you understand what pure substance is. Very simple. Any substance that contains only one kind of particle. So once it contains only one kind of particle, it is a pure substance. It must not contain an additional particle, an addition particle. No. And they must always have these fixed properties. Like I said, it must have a fixed property. And I gave examples of pure substances. Apart from distilled water, pure substances must contain the word pure in the term. So if you are talking about any salt, you must add pure to it. We are talking about any kind of salt, any kind of substance, add the word pure to it. So the other one, which is impure substance, is just like the opposite of pure. I will tell you how JAMB asks questions on these topics. Just bear with me. So, and impure substances, they are just substances that contain more than one substances that are mixed together. I hope that is taken. They are substances that contain more than one substance mixed together. I want you to write that down. They are substances that contain, let me write that for you. So that gift will not say, she did not write it down. So there are substances that contain more than one substances mixed together. So majority of the times, odd compounds are impure substances because they contain one or two substances that are mixed. Crude oil. Crude oil is an example of an impure substance because if we separate crude oil by fractional distillation, we can see different kinds of substances inside crude oil. So crude oil, river water, and every other compounds like that. They are examples of impure substances. And this is the key takeaway, the key point from the physical pure and impure substances. I want you to take note of this, please. Pure substances always have sharp melting and boiling points. What did I say? Pure substances always have sharp melting and boiling points because they will ask you. They can say a compound X or a substance X has a sharp melting and boiling point. Predict the kinds of substance X is: A, impure; B, not too pure; A, pure substance, and all. So pure substance always have sharp melting and boiling point, while impure substances, they melt or they boil over a range of temperature. Today they can boil at maybe 150 degrees C. Another day they boil at 190 degrees C. They don't have a stable melting and boiling point. They boil over a range of temperature. Are we together, everyone? I believe that is clear. Or should I write that for you? Let me come again for the last time. I said pure substances have sharp melting and boiling points. Why impure substances, they can melt or they can boil over a range of temperature. So they don't have a sharp melting or boiling point. That's just the difference. So pure substances, they have a constant melting and boiling point. For example, who can tell me the boiling point of water? Anybody? Gift, what is the boiling point of water? I believe you guys can hear.
I can hear you.
Uh-huh. What's the boiling point of water? I mean pure water.
I don't know.
Who wants to bail her? Hello, Justin.
Sir, is it 100 degrees Celsius?
Thought you told me you don't know.
I'm not sure.
You're not sure. But you are sure of your best food. Yeah, you are right. The boiling point of water is 100 degrees Celsius. So you can convert it to Fahrenheit or Kelvin. To Fahrenheit, that would be 212, right? And to Kelvin, you had 273, isn't it? So you can see that pure water, I mean a distilled water, it has an exact boiling point, like Gift had said, 100 degrees C, and it met at 0 degrees C. I mean pure water, it met at, but if it's a dirty water, it may not be 0 degrees C. It can met at -2, it can met at +2. It varies. But anything pure has a constant melting and boiling point. I believe we are together. So if it is impure, it varies and it has a range of melting and boiling point. That is just the difference between melting point and boiling point. Is that taken? Please, is that taken? So we've talked about pure and impure substances, boiling and melting point. Like I said, boiling and melting point, they are tests for purity. So what it does is that they help us to know if a substance is pure or impure. Boiling point is a point where a substance began to boil. If it is a liquid, that state, a substance began to change a state to vaporization state. While melting point is a state where a substance began to change the state to solid, from probably liquid to solid, like ice, for example. Water, it's melt at 0 degrees C, so it's changing from liquid to solid. So we use boiling and melting point to determine if a substance is pure or impure. Please, is that taken? So let's quickly go into the I want your response, please. Is that taken?
Yes.
All right, very good. All these ones are still simple for you guys, but I want you to pay because they will ask question on it. They can ask 2, 3 questions. We check, we go online together. We go online together to check past questions on this topic. So let's quickly go to element, compound, and mixture. That would be the third thing of 1.3. Element, compound, and mixtures. So that's the third thing we are considering now: elements, compound, and mixtures. So when we talk about elements, they contain, please, can you please mute your mic? Elements contain one type of atom. What did I say? Element, they are substances that contain just one type of atom. Let me write it down for you. Elements, they contain one type of atom. One type of atom. For example, all your periodic table elements, from the first to the last: hydrogen, helium, lithium, beryllium, boron, and on and on. So they are all examples of elements. They contain just one type of atom. But anytime you see something like H2O, H2O is not an element. Yes or yes? Why? Because hydrogen is an atom on its own. Oxygen is an atom. So this is not an element. Please, are we together? So we can only say something is an element if it contains just one type of atom. For example, if you say iron, iron is an example of element. You can say hydrogen. You can say oxygen. They are diatomic. You can say neon. We can say argon. Anyone you call it. These are examples of elements. Please, are we together?
Yes.
So the other one is compound. Compound. So compound, they are elements that are chemically combined together. Let me write it down for you. Compound, they are elements. They are elements that are chemically combined together. Please don't forget the word chemically, because the other one is physically when we get to mixture. So sometimes if you are not too careful, you will just quickly mixture is the answer, compound is the answer, and you switch the answer, you make a mistake and all. So compound, they are elements that are chemically combined together. For example, this water example that I stated the other time, water is an example of compound, isn't it? Hydrogen is a type of element. Oxygen is an example of an element. So they are chemically combined together to produce another substance entirely. Are we together? So that is why we have water as a compound. For example, sodium chloride also. Sodium chloride, 2 elements combined together, sodium and chlorine, to give us this. They combine together to give us this. So they are compound. So any element, or when 1 or 2 elements, you can see some other compound like hydrogen carbonate, H2CO3. They contain more than 2 elements and they are compounds. So when more than 1 element, 2 or more elements chemically combined together, we refer to them as compound. I believe that is taken. All right. So the last one is the mixture. Mixture. So mixtures, they are substances that are physically combined. They are physically combined substances. Do you get that? So any substance that are physically combined, they are mixtures. For example, here is an example of mixture. Here is an example of mixture. So any substances that are physically combined together, they are mixture. You can combine, let's say we combine salt and water now. Salt and water is an example of mixture. And that's why we need separation techniques to be able to separate this kind of thing. So we can separate salt from water, and we can also separate water from salt. We call these things salt dissolved in water or dissolved salt in water. So this is an example of mixture. Here, like I said, sand and water, soil, tea, and so many other things. In fact, some foods are mixtures, like milk. They are mixtures and all. So anything that is physically combined together that can be separated, they are mixtures. Are we together? All right. So that's all about let me highlight this. That's all about the 1.3, the elements, compound, and mixture. So we want to go to the fourth one, which is physical and chemical changes. I believe you understand what element is. Let me take it for the last time. Elements, they are substances that contain just one type of atom. So anytime you see anything, they just write one element. It is an element. Maybe they write chlorine, they write chlorine, iodine, or astatine, or any element, calcium, carbon, or anything. It is an element. Please, can you please mute your mic? So anytime you see elements that are chemically combined together, they are referred to as compound. When two elements combine together chemically, they are referred to as compound. For example, if you mix magnesium with chlorine, it will give you MgCl2. MgCl2 is an example of a compound. If you mix sodium with water, at the end of the day, it will give you sodium hydroxide and hydrogen. Sodium hydroxide is an example of compound. Please, someone should mute his mic. Who is? Okay. So, and the third one we spoke about is mixture. We said, Suzanne, please mute your mic, please. Thank you. So let's proceed, please. So the third thing we talked about was mixture. I believe you understand the difference between mixtures and compound. One is chemically combined together. Give Suzanne. One is chemically combined together, while the other is physically combined together. So compounds are chemically combined together, while mixtures are physically combined substances. So let's quickly move to the fourth thing for today. I think we are progressing well. So physical and chemical changes. Physical and chemical changes. So what do we mean by physical changes? physical changes, they are the kind of changes I'm explaining. I will give you notes that are reversible. There are some changes that are reversible. There are some changes that they are not reversible. So physical changes, they are the kind of substances that no new substance is formed and they are reversible. But for chemical changes, they are irreversible and new substances are formed. And sometimes for chemical change, you can reverse it, but it is not easily reversible. For physical changes, they are easily reversible. For example, water. Water can be reversible. Let's say water is in a solid state, it has melted. You can convert it back to the liquid state by leaving it to heat. Just leave it, it exposes to heat. Before you know it, it will change, to translate from the solid state back to the liquid state. You can change it from the gaseous state back to liquid state. By trapping it, we can trap water as a steam when it is going. We call it condensation techniques. So we can condense a water that is evaporating. So we can convert it from a gaseous state back to the liquid state. So all these things, they are physical changes. But chemical change, they are changes that occurs when new substances is formed, and they are not easily reversible. For example, a burning paper or a burning house. If a house burn, that's all. If you burn a paper, although you can use it to form another new paper entirely, but it takes a lot of bio and medical engineering. So it takes a lot of work for you to convert a burning paper back to the original paper, but you can convert it to an entire new paper through some processes and all. So that's just the difference between physical change and chemical change. So I want you to put this down so that we can quickly move into what we want to check today, which is method of separation. All these ones, they are just like an introduction to, because they'll be asking you a lot of questions on separations techniques, how to separate mixtures, how to separate mixtures. So let me just give you a note on the physical change and chemical change. So you can, let me write it down for you. So let's start with the physical change. So like I said, a physical change is a physical change is a change in which is a change in which sorry, let me erase this. A physical change is a change in which no new substance is formed. So simple. Nobody will ask you for definition. You can be lucky to see definition though, but it is just critical to understand it. You need to understand it. That's why I'm giving you the note for physical change, all these things. So the only thing that changed in the physical change is like the state, like the size, the shape of the substances, but it does not form a new substances. So in case you see a question, so the only the states, let me just give you only the states, the size, the shape of the substance changes. Yeah, that's just physical change. So, like example, like I said, the melting of ice into water, boiling of water and whole. If we dissolve salt into water, we can separate it. We can have the water back. We can have the salt back. That is a physical change. So the key point there is that in physical change, substance remains the same and they are usually reversible. There is no new chemicals that is formed. I hope that is taken. These are the key points you have to bear in mind. Number one, substance remains the same. It is usually reversible and no new chemicals are formed. Very, very important to take note. And for chemical change, let me just dictate that because of our time. For the chemical change, it is just like the opposite of physical change. A chemical change, I want you to write. Now, I told you guys we submit your notes. We submit your notes after 2 weeks. I will check your notes. So in case you are not writing, please do what to write. It is very important to jot things down. We are not brain jotter. That jots inside his brain. That's a joke. So jot things down in your notes. So don't say that these things are still simple. When we get to complex one, the simplest one will help you. You can easily go back to them for clarification purpose. So a chemical change is a change in which a new substance is formed. A chemical change is a change in which a new substance is formed with new properties. A chemical change is a change in which a new substance is formed with new properties. I will come again for the last time. A chemical change is a change in which a new substance is formed with new properties. Who can give an example of a chemical change? Anybody? Justice. Gift, Suzanne. One of you want to talk?
Burning of wood,
Burning of wood. Very good.
dissolution
Burning.
of metal, and limestone in acid.
Very good. So these are examples of chemical change. Justice, do you have any other example? And Suzanne. Hello, are you with me? Hello, Justice. I hope you guys are here. Is it only
Yeah.
Gift that is here?
Yes, we are here.
Rusted iron.
What do you say?
Rusted iron. Can you change that?
Yeah, rusting of iron. You are very correct. It's an example of chemical change. What about Suzanne? Suzanne, we are waiting for you.
Can I give one more?
What do you say?
Can I give one more?
Yeah, let me hear.
Cooked egg, is it a chemical change?
What do you say?
When you cook an egg, it cannot go back to the form.
When you boil an egg.
Yes.
Wow, you like egg, Gabby?
I'm just saying.
Yeah, that's right. Cooking of egg, yeah, you cannot return it back.
Baking of cake.
So you can also
Baking of cake.
classify cooking of eggs under cooking of food. Is that Gift that say cooking of food?
Baking of cake.
Eh?
Baking of cake.
Cooking of food or baking of food? What do you say?
Baking of cake.
Baking of food. Yeah.
Of cake.
So
Cake.
baking of cake. Yeah, it's under cooking of food.
Yes, sir.
Yeah.
Those are examples of chemical change.
So that's, I believe you guys understand You understand that already? So
Yes, sir.
the other ones, which is the most important thing for today, is the separation techniques. How can we separate mixtures? That is what we want to check. How we can.
By
So we'll be checking them one after the other, from probably decantation, magnetization, and all.
the
So
filtration,
let's quickly go to that. So let's move to, you can write a subtopic, which is I think that would be 1.5. So quickly write it down. That's a fifth topic for today. We want to check separation, methods of separation. Methods of separation. So I'm looking for my pen. Okay. So methods of separation. So after this, we will check past questions to check the 5 topics we've learned so far and see how jump we ask questions or have been asking questions. So let's also take method of separation. Now I've given you different methods in the introduction class. I said we have filtration, evaporation, sublimation, chromatography, distillation, simple distillation, fractional distillation, and many things. So let's just take it one after the other. Which one can we use distillation for? Which one can we use evaporation for? Which one can we use that? So let's start with evaporation. Let's start with evaporation. So evaporation is just, I want to explain first. It's just a process, a method of separating salt from salt water. When you can boil, when you boil or heat a solution, that the solvent can change into vapor. If the solvent cannot change into vapor, you cannot use evaporation. Please, are you with me? And that solid must not crystallize. It must not crystallize. It must not change its state. So evaporation is a process that is used of heating a solution so that that solvent changes into vapor, whereby it will leave the solid behind. That is evaporation. So until you can heat a solution and the solvent can disappear or changes into vapor, you cannot practice evaporation. No. It's not possible. Maybe you want to separate 2 things together, and after eating it, you find out that the 2 has disappeared. You cannot use evaporation to separate that kind of mixtures. You can only use separate evaporation when, after eating a solution, the solvent can change into vapor, whereby leaving the solid behind. I gave you an example the other time, salt water. So the principle for evaporation is the boiling point. That's the principle. In case they ask you, what is the principle or which separation techniques makes, or separation method makes use of boiling point? What is the answer? Gift evaporation. If they ask you, I will give you the other examples. If they ask you which separation method uses particle size, it is filtration. I will give you other ones as we continue. So I want you to write down the evaporation. So just write down the evaporation. Write down the definition. So the principle, like I said, the principle for the boiling point. You will see question on this a lot. a boiling point. So evaporation is just the process of heating a solution so that the solvent can change this into vapor, leaving the solid behind. Example is, I think I gave you salt water. So if you eat salt water, for example, maybe you mix NaCl plus water. Let's say you are applying heat. So at the end of the day, it can give us salt because the water will evaporate. This water will evaporate. So it will remain wholly salt. Please, is that taken? Is that taken, please?
Yes.
All right.
Yes,
So
sir.
the second one is let's move to let's go for simple distillation. So this method is just used to separate a liquid from a solution. A liquid from a solution, or you can separate a liquid from another liquid if they have different range of boiling points. But basically, simple distillation, the principle behind the simple distillation is it must have different boiling points. For example, which example can I give? Let's say alcohol and water. For example, if you mix alcohol and water together, you have to use simple distillation because alcohol has its own boiling point. Water has its own boiling point. So the moment it reaches the boiling point of alcohol, alcohol will be going. So there's a trapping funnel, a trapping column that we can use to trap the vaporization of alcohol. Then we condense it back to alcohol. And there's a way in which if we don't need the alcohol, you can just leave it to go into the air. And the only thing that will remain inside the beaker or the vessel that you are using to boil is your water. Is that taken? So we use the difference in boiling points of different substances to ensure separation. That is simple distillation. If you remember, the boiling point of alcohol is about 78 degrees C. Sometimes we say 78.4. So which simply means if you are boiling alcohol and water, for example, if you are boiling alcohol and water, A simply means alcohol, W means water. Let's say we have a beaker like this, and we have alcohol, we have water, we have water, we have alcohol, we have alcohol, we have water, alcohol. And you want to separate, maybe what you need is the alcohol. Maybe you want to be making alcohol, you want to have an industry that makes alcohol, or probably you need water. So you will subject this to eating. You will begin to eat this. As we are eating it, remember the boiling point for alcohol is about 78, just about 78 degrees C. And the boiling point for water is about 100 degrees C. So which simply means alcohol will first boil before water boils, right? So which simply means alcohol will begin to leave the beaker before water leaves the beaker. So once it reach 77, 78, you will see alcohol disappearing. Alcohol will begin to leave. Every alcohol will begin to leave. Every alcohol will begin to escape. So as at its escape, you can now find a column that will trap in. They will begin to trap in this alcohol, and it will condense back to alcohol here. So begin to have alcohol back here if you need the alcohol. So the only thing that will remain, so alcohol can boil. So once it's boiling from 78 degrees C, before it reach 90 or 85, alcohol would have left the entire beaker here. So the only thing that will remain inside here is just water. I believe you understand what I'm trying to say. So simple distillation is just a process of heating a solution such that you can separate a liquid from a solution, or you can separate a liquid from other liquid that has different boiling points. Please, the principle there is the boiling point. The principle of evaporation is what? What's the meaning of evaporation?
Boiling
What's the meaning for
point.
distillation?
Difference in boiling
Very
point.
good. Difference in boiling point. Evaporation is boiling point. Why simple distillation is different in boiling point. So you can just write down the definition that I gave you. Simple distillation is used to separate a liquid from a solution or a liquid from other liquid that has variable or high different boiling point. I want you to write it down. I want you to write it down. Simple distillation is used to separate a liquid from a solution. It's used to separate a liquid from a solution or to separate a liquid from other liquids with a high difference or large difference anyway in boiling points. The high difference in boiling points. Like aqua and water, like I've given you. This is very important. You know, I said in evaporation, you can use it to separate salt water, whereby you get your salt and all. There is this question that Jam always asks. They can ask you which separation techniques can be used to separate pure water from salt water. That is simple distillation. I wish you understand. Separating pure water from salt water is simple distillation because pure water has its own boiling point. Salt water has another boiling point because salt water is an impure pure water. Are we together? Because it contains another component, which is salt. So if they ask you what separation techniques is used to separate pure water from salt water, it is simple distillation, not evaporation. Is that taken?
Yes.
Please don't mix that together because it is always a common question. Some students, they don't pay attention. Once they understand evaporation, the principle of evaporation is boiling point. And when they say salt water, they won't pay attention because evaporation also is used to obtain salt from salt water. But if you want to separate pure water from salt water, it's not evaporation. It is simple distillation. It's the simple distillation. Let's quickly move to the examples that I gave to you. Let's quickly move to another type of distillation, which is fractional distillation.
Yeah,
Fractional distillation. What do you say?
you give us the examples of simple distillation.
I said water and alcohol.
Okay.
Water and alcohol, the pure water from salt water, kerosene and water, anything that has different boiling points. So we can easily use simple distillation to separate such thing. So there are some, let's go back. There are some substances that they have a very close boiling point. They are very, very close. I will give you an example. When we began to separate some larger components, maybe in organic chemistry, like crude oil, we have so many substances, components in crude oil that have relative similar boiling points. Now, the issue is that we not use simple distillation to separate them. No, we use fractional distillation. Fractional distillation is just like we call it the grandpa, the big boss for simple distillation. So what simple distillation cannot go, we carry it to fractional distillation. Yeah, oh boy, please come and help us. Oh, we have problem. Oh, you know, in every kingdom there's a king. The king for heat is fractional distillation. So simple distillation, there are some critical separation that it cannot solve. So anytime we have two or mixable liquids that have a very close boiling point, we cannot use this guy again, simple distillation. Now I told you we can use simple distillation for aqua and water. This is another thing that you need to pay attention to. Ethanol and water is even from aqua and water. Ethanol has a very close boiling point with water. So if you are separating ethanol and water, we use fractional distillation. I don't know if you get my point. You use fractional distillation, not simple distillation again. So there are actually some issue around simple distillation, but the separation techniques that you need to just understand is that there are some substances that has a very close boiling point. The most important one is in crude oil industry. They have a very close boiling point. So we use fractional distillation to separate it. So I want you to write it down. Fractional distillation. Fractional distillation is used to separate two or more mixable liquids with close boiling points. Fractional distillation is used to separate two or more liquids with close boiling points. With close boiling points. So the principle here is the boiling point. That's the principle we use here. A very close boiling point. I mean close boiling point. The principle we use in simple distillation is wide boiling point. I mean large difference in boiling point. But here we use close boiling point as a principle. Let's quickly move to example is the crude oil. Refining of crude oil or separating of components in crude oil. Let's quickly move to the fourth one because we are still going to question and answer session. Who want to be a millionaire? This time is who want to be a thousandaire? Sublimation. 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 So the principle we use here is for the ability of the solid to change to gas, to sublime. So there are some substances that can change their state from solid directly into gas without becoming a liquid first, because it is actually normal for substances to change to gaseous state from the liquid state. But there are some substances that can change from that solid state to the gaseous state without passing through the liquid state at all. So that is what sublimation techniques helps us to do, like camphor, for example, like iodine, like separating ammonium chloride from sand. So we can actually trap it because this substance can travel from the solid state to the gaseous state. So I want you to write down this definition. Sublimation. Sublimation is the process by which sublimation is a process by which Sublimation is a process by which a solid changes directly into gas. Sublimation is a process by which a solid changes directly into gas without becoming liquid. So how do we do the sublimation? How do we use sublimation separation techniques? There's a way in which we can separate a sublimable solid, that is a solid that can sublime, that can change directly to gas, from another solid that cannot be sublimed, that is unsublimable, that is not sublimable. So if you have two substances in a container and one can change directly to gas and the other cannot change to gas, you can use sublimation. Before you know it, one has changed to gas. If you need the one that has changed to gas, you will use a column to trap it. But if you don't need the one that is changing to gas, the other one left in the beaker, you can make use of it. So it is used to separate a sublimable solid from non-sublimable solid. It is used to separate a sublimable. Let me just write this one for you. So it is used to separate a sublimable solid from a non-sublimable solid. So that's about sublimation. So I'll give you an example. If you want to separate camphor from other substance, camphor can change easily to gas from solid. If you want to separate ammonium, I know ammonium chloride from sand, for example, ammonium chloride can change directly to gas. So you can use sublimation. I hope that is taken. So the technique is sublimable solid. Any solid that can sublime, that can travel, that can change its state from solid to gaseous state, we use sublimation separation techniques to separate such substances. Please, are you getting it? Please, are we getting it?
Yeah, sir.
All right. The fifth one is filtration. Filtration. We are progressing easily. They will ask you a question on this. You can go and check past questions. I told you, go and buy a past question, jump past question on your topics, on your subjects. Sorry. You will see what I'm saying. I have so many questions in my um, data banks that I can show to you. So they will always ask 2 to 3 questions in separation techniques. So once you understand it, it's just like a cheap question to you. So the fifth one is filtration. Let's quickly move out of our time. Filtration. From the word filtration, we are very conversant with the word. It's just a separation techniques that can help us to separate a solid that is insoluble. Maybe you mix two things together and you can see it with your cocoa eyes that these things, they are not mixing. So you can separate it with filtration using a filter paper and a funnel. So for example, maybe you mix a salt with a water in the laboratory and you find out that the salt is downward, the water is upward. They form two layers. They are hints, they are not, it is insoluble like that. They are not mixing. It is not becoming a mixture. So what you simply do is that you can use a filter paper, pour the whole substance inside a filter paper. So the residue, which is the salt, will be retained on the filter paper while the filtrate will enter into the beaker. So you can, if it is the filtrate that you want, you do what you want with the filtrate. If it is a solid, which is the residue that you want, you do what you want to do with it. So let me just give you the definition for filtrate. Filtrate is used to separate an insoluble solid from a liquid. It is used to separate an insoluble solid from a liquid using filter paper and a funnel. It is used to separate an insoluble solid from a liquid. It is used to separate an insoluble solid from a liquid using filter paper and a funnel. So the principle we use here is difference in solubility. In case they ask you, what is the principle in filtration? Please, I want you to be writing down this principle. You will see questions on it. The principle of filtration is what? Difference in solubility or difference in particle size. Difference in solubility. So the solid will be trapped in the filter paper while the liquid will pass through. Hope that is taken. The solid will be trapped while the liquid will pass through. Example is probably they mistakenly mix water with sand. You can separate sand from water by using filtration. So let's move to the sixth one, crystallization. Please, if I'm dictating and you're not getting it, please tell me. So I'm just trying to dictate so that we can move very fast. Crystallization. So this one is a method that is used when we want to obtain a substance in a pure form. In a pure form. That is when we use crystallization, especially for something like sugar, for salt and all. So that is what we use crystallization for. Let me just give you the notes. Crystallization is a process. Crystallization is a process of obtaining a pure solid. Crystallization is a process of obtaining a pure solid in crystal form from a solution. It is a process of obtaining a pure solid in crystal form from its solution. It is a process of obtaining a pure solid in crystal form from its solution. So the principle behind crystallization is difference in solubility in a solvent at different temperature. You know, the filtration is different in solubility or particle size. But this one deals with temperature. So this one deals with eating. In filtration, we don't eat. We only do we only use filter paper to separate. But this one is different in solubility of a substance in a solvent at different temperature. So the way they always confuse students, especially from the filtration and crystallization, is that the two talks about difference in solubility, but one talks about a different temperature. Crystallization talks about a different temperature, while filtration does not need temperature. It is just a physical separation technique where you just need to pour your solution into a filter paper where the solid is trapped in the funnel in the filter paper and the liquid pass through inside the beaker. But crystallization talks about different in solubility at a different temperature. They get it?
So please, can you come with me with the definition of crystallization?
I said crystallization is a process of obtaining a pure solid. In crystal form from its solution. Is a process of obtaining a pure solid in crystal form from a solution.
Thank you, sir.
They get it?
Yes, sir.
All right. So,
I have a question.
Okay, what is that?
You said the principle of filtration is what?
Difference in particle size or solubility. Solubility simply means when you mix two substances together, you can see that they are not mixing because they are not soluble together. For example, if you mix sand and water, they cannot mix. Sand will go downward while water will remain upward. So you can use filtration. You could be pouring that solution inside a filter paper, a funnel, and the sand will be trapped inside the filter paper while the water will go inside the beaker. That is filtration. Crystallization, the principle is different in solubility of a substance at different temperature because crystallization involves cooling and heating. It involves partial evaporation because you have to heat in crystallization, but in filtration, you don't heat at all. You like heat, HEAT. You don't heat the solution at all in filtration, but in crystallization, you heat. That's why I'm saying that sometimes they can confuse filtration principle to crystallization principle. If you are not if you don't pay attention, for example, JAMB can ask you that the separation techniques that use different insolubility of a substance at different temperature is dash. And students that are not very that are too anxious, they just quickly pick filtration and they are wrong because they've added at different temperature. It is no more filtration, it is now crystallization. But if they do not have different temperature, maybe they just ask you the principle of a separation technique that is based on difference in solubility is dash. So since it's only different in solubility, it is just filtration. Do you get the differences now? Hello? Hello?
I heard what you said.
Do you
Thank
get the
you.
differences now?
Yes.
All right, very good. So let's quickly go to chromatography. We have about okay. We have about 6 or 5 more separation techniques to go. We have about 5. So let's be fast so that we can quickly treat questions and we call it a day. Oh, okay. Let me do chromatography. Then we'll check questions together. So let us end it at chromatography. So next class we will continue with the other one. I want us to check questions in every class. So in chromatography, we have 2 types of chromatography. We have the paper
Wait,
chromatography. What do you say?
you didn't give us you didn't give us examples of crystallization.
Organization I gave you, for example, if you want to produce sugar crystals from sugar solution, you need crystallization separation techniques. Salt crystals from
Yes.
salt solutions, you need crystallization. If you want to prepare drug, also you need crystallization. So sugar crystals from sugar solution, salt crystals from salt solution, all those things, crystallization. How that is taken.
Yes, sir.
All right. So let's quickly move to paper chromatography. Chromatography. Sorry, I'm coming. All right. Let me write. So this will be the last thing we will check for today so that we can check past questions. Everybody will be answering one after the other. So in chromatography, like I said, we have 2 types of chromatography. We have the paper chromatography and the column chromatography. The paper chromatography, let's start from there.
So how many types of chromatography do you say we have?
For your level, it is 2, but we still have more. But those ones are advanced. We have gel electrophoresis. We have, but for your level, I mean, JAM syllabus. You know, we are working with your syllabus. So I don't want to teach you things that you don't need for now. It's just paper and column.
Okay, that means we won't be treating thin layer and cash.
We have paper chromatography and column for your level. They cannot ask you question beyond. They cannot. So what we use paper chromatography to do is that we use it to separate and identify colored substances. I want you to write it down. Paper chromatography is used to separate
Separate.
and identify colored substances. It's used to separate and identify colored substances based on their different rate of movement on paper. Paper chromatography is used to separate colored substances based on their different rate of movement on paper. So if you want to separate dyes or you want to separate ink, for example, you use paper chromatography. So it will be absorbing colors based on how colorful they are. So paper chromatography is used to separate and identify colored substances based on their different rates of movement based on that. So the chromatography, the principle is different in absorption of substances. Different in absorption, how they adhere, or you can call it affinity. Anyone. Different in absorption of substances. Different in absorption. So paper chromatography is used to separate. Let me just type it. It's used to separate and identify color substances based on their different rate of movement on paper. So example is you probably want to separate dyes, you want to separate ink, anything colorful, we use paper chromatography. Maybe you are trying to test for ions using their colors. Oh, calcium has so color, copper has blue color, iron has big red. So you have different kinds of ions in a compound and you want to isolate different substances. You can use paper chromatography because each ions will produce its color on the paper. The next one, which is the last one for today, is column photography, column chromatography, not photography. Sorry, column chromatography. Column chromatography. So this will be the last one we check today. That we can quickly consider one or two things for the. We just do like 5 past questions or 6, and we call it. So column chromatography separates substances. Column chromatography separates substances based on different adsorption strengths. They separate substances. Paper chromatography separates substances based on different colored substances. While column photography separates substances based on different adsorption strengths. Column chromatography separates substances based on different adsorption strengths as they pass through a column packed with an adsorbent. As they pass through a column packed with an adsorbent. As they pass through a column packed with an adsorbent. As they pass through a column packed with an adsorbent. As they pass through a
Sir, please,
column
can you
packed.
type it?
What do you say?
Can you please type it, sir?
I should type it. Hey, yeah. Okay. So let me quickly go and look for the questions so that we can. Are you using this? Are you using
I'm
that?
still writing, sir.
Okay.
I'm still writing, sir.
Can we proceed?
Yes.
Okay. Because of so
Yes, sir.
examples of column chromatography, we can use to separate um, maybe when we want to do drug design to identify drug components or to separate drug components, and also probably for phytomedicine people, I mean plant medicine, you can use to separate plant pigments also. So these are the major two examples: separating plant pigments or to separate drug components. So let's quickly move to question and
Sir,
answer.
that's
So
an example.
what do you say?
Okay, what you said now, that's an example of what?
Column chromatography to separate plant pigments or drug components.
To separate?
Plant pigments or drug components. So these are jam pass questions. You'll be taking it one by one. I will start from Gift, then Justice will take the second question. Gift will take the first question. You know the rule of the game. The question, the third person will take Suzanne. Everybody will take one question or the other. So there's no 50-50. You cannot call a friend. Nothing, nothing. So these are past exam questions. So everything that I've taught you today, I will be fetching it from you from the data banks. So Gift will go first. Justice will go second. Suzanne will go third. So the first question is for Gift. Do you get how we're going to do it?
Yes.
Okay, so what's the first question? So which method is most suitable for separating mixtures of ammonium chloride and sand?
Sublimation.
Very good. Can you explain?
Okay. Because ammonium chloride a sublimable substance, like it can evaporate in the presence of oxygen.
Very good. Why sand cannot? So sand will remain.
Yeah.
Ammonium chloride will disappear on heating. Do you get it?
That you have to do, sir.
Yeah. So let's move to the other question. Clap for yourself. You are forming big hair. You don't want to clap. Uh, let's go to question 2. So Justice, are you with us?
Yes.
So over to you. A pure substance can be best be identified by its hmm? Hello, Justice.
Huh?
What's the answer? By 5 seconds, you should be able to answer it. 5 seconds, 6 seconds.
Okay. The person can be best identified by its color. taste, sharp melting
No,
point,
no, no, no.
density, sharp taste, sharp melting point. By its density.
No density, no density, no density.
Okay, I'm sorry, sharp melting point. Nice. Right.
Yeah, it's sharp melting point. I told you, one of the ways through which we can know if a substance is pure and impure is from its melting point and boiling point. A pure substance has a sharp melting point and boiling point, while an impure substance has a very wide range of boiling points and melting points. Do you get that?
Yes.
All right, that's good. So, Suzanne, my friend, how are you? Over to you.
Fine.
Uh-huh. So, this is your own question. Down 2015. Which of the following mixtures can be separated by fractional distillation?
Sand and water.
Hmm?
Sand and water.
Sand and water.
Yes, sir.
Oh, are you forgetting what we use fractional distillation for? Sand and water is not for sand and water. We use filtration. You don't use. Who want to help her?
Can I try?
Oh yeah, let's see.
Oil
Yeah,
and water. Oil and water.
oil and water. No,
Is ethanol
Okay,
and what?
sir.
it's ethanol and water because oil and water is for simple distillation. Ethanol and water has a very close boiling point, so you need fractional distillation for close boiling point. You guys are forgetting. I need to visit your house. It is ethanol and water. I told you simple distillation, they are used to separate mixtures that have a wide range of boiling points. While fractional distillation is used to separate mixtures that have close boiling points. So ethanol and water, ethanol has 78.4. Some people say 78, some people say 80, but around 78.4 to 70 to 80, sha. And water has 100 boiling points. So it's just minus 20 degrees C. So it is ethanol and water. Hope that is taken.
Yes, sir.
You can go through the notes again. I've teach you before. I've taught you how to do that. So these are the questions that you'll be expecting. They will ask this question. So over to you, Gifts.
The answer is C, chromatography.
Why is it chromatography?
Because it's used to separate and identify color substances.
Very good. That's good. Yeah. Well, let's proceed. Let's do like one more questions. One more. And we go. So others go and look at jam pass questions and treat every question under separation technique. Anyone you don't know, you can bring it to the next class and we'll start from there. So Justice, over to you.
I think burning of candles.
Burning of candle. Physical change. If you burn candle, can you get it back?
Yes, I think if you keep it, like if you bring it together, it will form back to candle.
Eh? Are you sure? Eh. You want to work in the industry, Abby?
If you melt the candle, I thought it can go back to its state.
No. If you use a candle, don't go. Anytime you hear the word burning is for chemical change. Anytime you hear the word roasting, I'm giving you a video. Anytime you hear the word burning is always for what? Chemical change. Roasting is always for chemical change. So I told you the other time, I think I gave you an example that when you dissolve salt in water, you can get your salt back, you can get your water back now. What separate techniques can we use? Gifts to separate water from salt from water.
what do you call it again? The
Ah, what do you say?
Super
simple
filtration.
distillation. Simple
Distillation?
distillation.
No,
Wait,
Ah,
it's
is it
boiling.
salt
filtration.
and water
Evaporation.
or okay? I thought it's like salt solution and water.
No, that one is salt water and salt. Oh. This one is salt in water. So it's
Okay.
evaporation. Oh. As you are heating it, water will be disappearing. Only salt will remain in the
Yes.
pot. So if you need the water, you will trap it and convert it back to liquid. But if you don't need the water, you leave it to disappear and you leave only the salt. So this is a physical change. Justice, hope you get it. So
Yes.
after the class, I want you guys to just go online, or if you have past questions, go and be checking past questions on separation techniques and physical. All the 5 topics, we've checked 5 topics today. We started with mixtures. I've forgotten how we started. We shall check boiling point, melting point. We check mixtures, elements, compound. We check purity and impurity. We check separation techniques. Go and check questions on all these topics so that you can get familiar with it. Okay, let's move to Susan, my friend. You must get this one, or else I will come and sue you. All right. So answer this question. Pure crystals from an impure solid. Pure.
Crystallization.
Clap for yourself. She, she said it with a lot of confidence. Crystallization. Yeah, all right, that's good. So I believe you guys are understanding it a little by little.
Yes,
Yes, I
sir.
don't want you to miss any question under the first topic. At least you will see 2 or 3 questions there, and it should be a bonus for you. So let's go back to gifts. This 2020 coming. Huh? I've not teach you this. We've not gotten there, but let me see if you get it. It was also that also under separation, but I've not teach you the it's remain for separation techniques that I've not taught you. So gifts is a try. A mixture of iron fillings and sulfur powder can be separated using what?
Magnet.
Very good. Is magnetism. That's magnet. So anytime you hear the word magnet in your question, like iron, aluminium, it is anything that can attract magnets, it is magnets. So looking at it, you can never be filtration. It's not sublimation, it's not chromatography, so it's magnets. So gift is winning today. Oh. You've answered 3 out of 3. Do you want to collect my money, Abby? Don't worry. I will give it to you. I promise you. All right now. Question 8. Justice. Which of the following properties is used to separate crude oil into fractions? Aha. I like this question. What is a
Is the P
principle
and
for fractional distillation? That's what they're asking here.
okay.
Anytime you hear the word property, you heard the word difference, properties principle.
I think
Yeah,
it's boiling point.
very good. It is boiling point. Yes, because they have, fractional distillation, we use very close boiling points. For difference in boiling point, if it is simple distillation, it is wide. If it is fractional distillation, it is close. So for put oil into fractions, we use boiling points. Every component, the travels at different boiling points. So we use boiling points there. So the last question for today, which is for Suzanne, the justice got 2, gift got 3. Suzanne, this is your question for you to get 2 also. The separation of a mixture of kerosene and water is best achieved by kerosene and water. I've not taught you that. Can you try, Susan?
Separating funnel.
Very good. Clap for yourself. The separating funnel. We use separating funnel to separate two immiscible liquid. I will teach you that. I think we have chemistry class tomorrow. Two immiscible liquid. So that is what we use separating funnel to separate. So we understand what distillation does. We understand what filtration does. We understand what chromatography does. So this is the answer. Two immiscible liquid. Very good. So I have a question here, which is the last question. I just saw it now. So after this one, we'll call it a day. Anybody can answer this if you know it. Which statement correctly distinguishes a compound from a mixture? Anybody? Put your hands up in the air. Answer it.
Mm.
Any idea? It is question on
I think it's C.
is three. But what do you say?
C.
A compound has
No,
definite chemical
D. I
property.
mean, no, it's C. C.
Who is
Answer
talking?
is gift.
Gift. What do you want to give me as a gift? Yeah, you are
Banana.
right.
B is the answer.
C is the answer.
C.
Compound has fixed chemical properties. Compound has fixed composition. They have definite chemical properties. A compound cannot be separated physically. I said they can only be separate. They cannot be separated physically. And a mixture has fixed composition. No, mixture doesn't have fixed composition. It is compound that has fixed composition. The third one said a compound has definite chemical properties. The last one said a mixture contains chemical. No, mixture does not contain chemical combined substance. It is compound that contain chemical combined substances. I believe that is clear. So you can
Yes,
go
sir.
ahead and just check more questions on the topics we've learned so far. I believe you understand the 5 topics that we check today. And if they ask you, okay, let me ask you, Suzanne, if they ask you question on separation techniques, how many of them can you answer? The other assuming you see like 4 or 5 questions in your jam.
By the grace of God, I can answer them. I said, by the grace of God, I can answer them all.
You can answer everything. I love that confidence. That is it. You can answer. You can see all these things are very simple. Once you understand the definition and the principle, there is no question you cannot understand. And I gave you all the principles. I gave you how they works. I gave you practical examples, so you should be able to answer. All about justice.
I will be able to answer all.
I love you, my guy. Eh, gifts. How about you? A lady that doesn't have best food. I don't know how you are doing it. Oh.
I can answer all of them.
You can answer all.
Yes.
Yeah, that's good. Yeah. So I think we are progressing well. So this is your assignment for today. Go to your past questions, the hard copy that you have. Check every questions on separation techniques. Answer everything. And once you are done doing it, write done in your group. Just write done. If you write done and you're not done, I will done you. You will see. So just write done once you are done. Check all the questions in your jam pass questions. I don't know if you have soft copy or it is hard copy that you do. Check it from the first year till the last year. Any questions pertaining to what we learned today, be doing it. Like do it from now to tomorrow. Use it as your night work. So that will be the end for today's class. We will meet again tomorrow by God's grace. Do well to have a good day. I love you. Yeah, bye-bye. So Justice, you can go. Gift, you can go. Yeah, thank you. Suzanne, thank you too. Thank you for joining us. Please don't come late tomorrow. Let's come early so that we can finish on time.
Babakunde, well done, boss.
Thank you, boss.
You can save the recording now.
I stopped it just now. I said your video call is being recorded. There, it should include captions in the recording. Also stop transcribing or what?
Yeah, just to save it, yeah.
Yeah?
You click on that red, I'm seeing that it's still recording. That red icon, I'm seeing that it's recording or something.
Yeah, it's still recording. Should I include captions in the recording? Suzanne, do you want to say anything?
Okay. I don't. Is it important to include captions? I don't think so. Just
Okay, what about also
notes.
stop transcribing? Should we mark it?
Stop transcribing. I think that's for note taking. Yeah,
Yeah.
just everything. You have to, yeah, just to close everything. It is safe to
Okay. Okay.
Well done so much, bro. Has it saved?
Yeah.